Hey kids, it's Jurassic James, and on this Jurassic James Explains, we're looking at Amargasaurus. Now, same rules apply with the older models to the newer models, and my newest right here. And there's a lot to unpack with this animal. So first and foremost, the name Amargasaurus comes after the Amarga Formation in South America, in Argentina particularly. Uh, to translate it, it's Amarga's lizard, Amargasaurus, Amarga's lizard. The Amarga Formation basically means bitter, so it's like bitter lizard, but don't think it means a representation of the animal. It's more of a locality because there's a lot of other Marga something dinosaurs from that region, basically. Now, that being said, my first understanding or experience this animal was this model here, which I got at Dollar General in the 90s. That was the last century, kids. So the idea, basically, I saw this figure. I didn't know what it was. Amargasaurus was first uncovered in 1984, the Wonder Woman sequel title, and it wasn't written about until 1991. And again, it's very common to find a fossil, take years to prep it, clean it, check it out, and then write about it, publish it. So one thing to point out that stuck out is that the first thing, it was a sauropod, a long-necked dinosaur. And the idea is that sauropods, we think of them as the, quote, Brontosaurian or Brachiosaurus, these large animals. Amargasaurus is only about 30 to 33 feet long, which is very small for a sauropod. And again, I always say small for a long neck, but like the example I give you, if they were walking around today, they're like the biggest animal on land. But again, in the dinosaur world, in the sauropod group, that's a really small animal. Now, the thing that sticks out the most are this right here. So it appears as if there were two Dimetrodon-like cells on its neck. And again, there are these tall spines here that are found out. The thing obviously it's our first model, first early example. They are different sizes, and the first one's kind of arched backwards. Plus, I want to point out the hands, the forelimbs. We didn't find the Amargasaurus forelimbs, but it's a cousin of the Platypus. That's its closest popular relative. The group is called Cretaceous, and there's Cretaceous itself was found in South America. In Africa, late Jurassic. And Cretaceous are again a small sauropod type, and they were found way earlier. But by finding Amargasaurus, we now know, oh, it's a family group. It's more than one of these things, or one species of this. So that's where the name comes from. Regardless, the forelimbs here look more like hands, and I'm not sure if the design was to like be rearing up or whatever. I don't know, but that would be incorrect. What we would assume is what we would see in the other guys, where there is like a nub fist thing with one claw. Again, we don't have the forelimbs, but that's what we would assume, right? The back feet, again, this is very, quote, generic dinosaur toy look, where there are 5 toes and they're kind of like little finger-like toes. Again, sauropods, they have, the first 3 would have claws, and then the others would be like nubs, and it's like a big fleshy pad in the back. This is not showing that as well. Tail arches up. Again, I think the issue with dinosaur toys is the tails are always going to be smaller or arching or changing because they have to fit in packaging. So again, it's not like a perfect figure, but it was the first one I ever had, so yay. There's a company called Dinosaur Valley, and they switched names since then, but this is one of those little like packs. Now, this guy, it went backwards because we know there are 2 of these things, 2 of these rows here, right? Of spines. This one only has 1. And what's really weird about it is that the way we do know that the true sauropods, you've heard of prosauropod or sauropod and then true sauropods, these sauropoda, their hips tend to arch this way, making the animal look up, go upwards. But Amargasaurs and their Cretaceous in general, their spines arch the other way. So this guy having this like almost brachiosaur-like shorter arms, long arms, shorter legs look is something we don't see in this group or its lineage. Overall, like I said, I always tell you guys, if the figure's not correct scientifically, but you like it, go for it. The Jurassic Park raptors are entirely made up. They are not real at all, but I think they're really cool, so I get it, right? Same company, different, larger model. And again, this guy retains the 1 row of spines there, which is incorrect. And also there's a row of the cell in the back. Now, what we do know is that there are actually 2 separate, these neural spines, and they converge to 1, which we're going to see in a later model. And the tail's way short. Now, we didn't find the end of the tail, but Amargasaurus and Cretaceous in general are relatives of the Platypus. And the term, the grouping for those 2 is flagellar. So flagellate whip and caudal tail. So we assume there's a longer tail than that. But again, they didn't find it, so I get, But also, I'm guessing this is engineering or it's just compacted. The feet all have 5. The standard elephantine 5 toes and hands. It's not, it's correct for this group. But overall, the animal, it gets some point across. The teeth look like they're a carnivore, like it's ripping apart, tearing apart flesh. Um, the Diplodocus, the Diplodocoid group, imagine their mouths kind of like rakes, and their teeth are very simple pegs, and they bite the leaves, they strip them and swallow them whole. They don't chew them. They use stomach stones, gastroliths in their gut to crush the food for them, we believe, and a lot of bacteria too, in different vats. These teeth look like something that's gonna like bite and rip apart someone's neck or something. Anyway, so with these guys, my 90s figures, the 2000s ones are more science based, right? So the first we have is the Carnegie or Safari. It is the Safari. This is my first science Margosaurus. The one thing I want to point out that it's, they're at least trying, they're getting to the point. The feet are correct. There are the 3 main toes and a small little nub on the side. The hands, again, the forelimbs, you don't know they look, but they get that general pad and a thumb spike we see in Diplodocus. It is correct in that you can see there's 2 rows and then they converge into 1 row in the middle right there. So that's something that's really correct finally. And the tail comes to a little whip-like design. We don't know for sure, but again, it suggests that. The one thing that's missing is that the first pair of spines are actually 1. There was like 1 spine and then they bridge into 2. This guy's missing that, but again, given the time, I mean, that was well known anyway, but given the time, and its comparison, this is like light years ahead of the others, right? But overall, really cool little figure. And the thing is, the skull, I believe, is too small. We didn't find a complete skull. They found the brain case. Sauropod skulls, again, pop off. They get lost. They're the front of the face are often very small, thin bone, so they don't fossilize very well. But based on studies of the brain case, it suggests the head would kind of like sit like this, mainly, when they're feeding. They could still lift up, but their resting pose is like this. It's like your hand. You can, generally speaking, you can do all of this at your hand, but it kind of, your resting position is like here. The resting position for it would have been more like kind of going down like this. And the head, again, based on what we know, is a little too big. But I give them credit for the time of discovery of this model making. We didn't know that. The next one, let's see if I remember correctly, this one is 2008, and it's who is this? Procon, yeah. So it is correct in that it has, what? No, does it? Yes. It has the first spine being singular. So that first, I'm going to kind of bend it forward. That first spine sits by itself. Then there's 2 rows, and then there's where they converge here. Whether or not there was a sail on the spines here, we don't know. One thing to point out is that the original paper described it as not having a sail, and the analogy was more like the modern aurochs or the ibex, these 2 kind of goat relatives, basically. And the idea is that they would have, they both their horns arch backwards, and that looks like it's not very protective. But the animal puts its head down, and all of a sudden it's a weapon. It wasn't until later on that the idea of having a sail on his neck was put out there. But again, it was suggested but not really supported. So most paleontologists I know about, papers I read, suggest that it was probably just spines, right? The next one here is really special because what I don't like about this, I'll say that first, is that it's the legs, the way it's the stance. Even though it was smaller, sauropods generally have their legs like directly into their bodies. This kind of pose like this. That's kind of weird. Again, the larger sauropods would have had their legs very straight, and it's been theorized to only lift 1 leg at a time, kind of thing. They're really, really big ones. Amargasaurus is less than 40 feet long, so maybe that's some concern, but it's still a sauropod, right? What it does correctly, in my opinion, is, again, it has, the cells there, we're not sure about that, but it does have the point where these neural spines in the back, there's 2 set, and they converge to 1, right? That's really cool. The hands or forelimbs are, again, what we expect. They have the mitten, not most of the hoof-like thing with a spike. The toes have all 5 toenails, which you wouldn't see in sauropods. But again, it's a pretty nice figure. It gets the point across. The skull's too big, and that's the thing that I think we as humans don't understand, is that we live in a world of large mammals, and mammals have third-sized heads because of our brains for the most part. With sauropods, they had just tiny heads compared to their bodies. It's really weird looking by our standards. This guy here, if I remember correctly, is Collect A, one of the larger models, and it has, again, it gets the point across. I won't say it's bad because again, so the feet have the 3 main toes and the little nubs on the side. The forelimbs have more of like the fifth kind of the hoof-like thing with the spike. I like that the neural spines converge to this one right here. The tail is short only because we don't know for sure because we don't have the whole tail. I'll give them that. Now the spines on the back, it has the one. Well, that's weird. Actually, it has the one when we know that's there, and there's a small one there that shouldn't be there. And there's 2 separate rows of these guys. And again, when I first saw this animal, I was like, that's really cool. Its closest cousin of Amargasaurus, or one of its closer cousins, it has a toy. It's Biosaurus. And so when I first saw Biosaurus, my first thought was, is this like sexual dimorphism, where like the males have them going forward, the females have them going back, or vice versa? But again, it's important to know your geology, that in early Cretaceous South America, there's different formations, different levels. So Biosaurus is up down here, Amargasaurus is later. So the idea is that they wouldn't have been the same species because they're from different times, basically. And even if they lived in the same environment, like they're the same level, we wouldn't know if they were different species or not. I mean, sometimes you find them in the same bone bed, like Shriosaurus from like a couple weeks ago. But the idea is that even then it could have been a drought area they were washed to, or if their herd was together and died together, that will say that one thing. But the fact that these two were separated by time and rock layers, that means they're not the same species. Anyway, so that being said, the length of the spines, they are generally shorter in the front and longer in the back in the bone portion. But there are studies showing that the core horn, think of a cow horn, the skull's there, here, and the horns stick out. There's the core of the bony horn and the teeth covering it, making it longer. So with these guys being shorter and these being longer, there's a suggestion that maybe they may have had longer projections than these guys because they were, so it sort of looked more uniform. But again, we don't know. One of the hypotheses earlier on, and I'll use this one as an example, the Safari 2018, that if they are these elongated spines, then maybe they can like move them together and make like a noise. So interspecies, meaning within your own species you're fighting, right? So everyone's fighting, all the buffalo want to fight lions. Don't eat me, bro. But within the species, the males are fighting to compete for females, or territory, or whatever, right? So these behavioral things are way far removed. We barely understand how the anatomy works, or are arguing about the anatomy working, much less how it behaved. So for it to shake those spines on its neck, make all this noise, that would be pretty cool, Well, probably a really eerie noise. But anyway, I digress. This guy, is in my opinion one of the more accurate of these guys, for the most part, because again, you can see those very clear toes, those 3 toe claws, and then you can see the other 2 digits on the foot have essentially been reabsorbed, below in skin. The forelimb has that hoof thing with the spike. The spines are not covered up. There's one. No, they did it again. There should be just one single spine, and basically the rest double off. Now, what's really neat or weird that they're doing here is that this part, these tall neural spines in the back, they're suggesting that they are actually just one solid hump. Again, different interpretation. I've seen multiple papers and ideas and arguments and debates. Some say it was all just one giant hump. Some say it was all spines. And honestly, in my opinion, all the toys show the variety of this design. It's like, maybe it's this, maybe it's that. Not counting the 90s ones, the 2000 ones are all trying out the different designs. One saying that, yeah, it's all one thing, but it's still split. And one saying, no, it's all together with skin, with being, tendon, something like that. It's being debated. But again, for me personally, this is like, the stance is kind of like, it's very active. Looking at the bone, the size, they are, compared to rhinoceros bones, and like I said, different animal, different clade, but it's more active than you would think for a sauropod. When we think Brachiosaurus, these massive animals, these are pretty big with their, elephants can kind of get moving, and it's about elephant size, not counting the long tail and neck, right? So this is, I think, my most accurate one. And even the teeth kind of jet out front. Now, we don't have a Amargasaurus, we don't have the back of the head, but compared to other Dicraeosaurus like Biosaurus and the Cretaceous itself, they have like these little peg teeth like the Diplodocus. This one doesn't have a year on it. It is Papo. But the main thing, it does have that first spine by itself. But one thing to point out too, that first spine is actually, if you were in a cross section, it's like V-shape almost, or little grooves in the middle. So it's thought that even though it's a single spine, it would have led to, if there were skin too, it would have led the cell to attach to it too. But again, most are leaning towards no cell. But again, it seems to cover all of the double neural spines into a giant cell. The tail, I actually like the tail here. It's pretty decent size. The feet have 4 claws, not the sauropod 3. And the hands, of course, are pretty decent. They have like the standard hoofs kind of thing. So this next one is important, and why I did the video today, because a friend of mine, a former person I mentored, he has got a job at the Cincinnati Children's Museum as a paleo prepper, which is to get a job in paleontology and like a full-time paleontologist. It's a big deal. I'm very proud of him. His name is George Plata, and he gave me this as a going away present. And he's saying, James, he was going away and he gave you a present. Yeah, I have that swag. Now, taking the official scissors of Jurassic James video reviews, we're going to open up. Now, this is PNSO, and I have been very reluctant to get into PNSO, but I mean, I did my Safari, originally Carnegie, Papo, Schley, but PNSO was seeming pretty exciting. So give me some packaging here. We have the packing sheet, so they're the names PSNO. They named their dinosaurs, so it's Romario the Amargasaurus, and it's a baby actually. So they are, to this date of filming, there is no evidence of, there's no evidence there were baby dinosaurs. We know that there are baby Amargasauruses, that's why they get more of them. We have no fossil evidence of a baby Amargasaurus. So we have no idea what it looks like, but I will tell you this, it is, what we usually do in the science world, or theorize, is that you take an adult and you take away his horns and spines, because those have been, smaller and less developed, and you give it bigger eyes and reduce his necks, all these features, right? Especially for sauropod. Sauropod babies had short necks, because why would you have a long neck in your egg, So again, that's one thing I forget to point out too, is that we look at these dinosaurs and these large animals, and we forget that they all started out from eggs like that size and got bigger. That to me is really cool, considering how mammals start pretty well developed for the most part. Let's see. So that's fun. There. Caught him. It's a boy, Mazel tov. So, wow, that's this little guy here. So you're seeing my first baby Amargasaurus. So again, it has the little nubbins for the spines right there. So the idea is that if it's a baby, all of its features are developed. PNSO does have an adult Amargasaurus, and actually Jurassic World has an Amargasaurus figure. Those two are on my wish list. So I was waiting actually to buy the Jurassic World Amargasaurus figure, which has been out for like a year now, to do the video. But when George gave me this one, I was like, okay, fine, I'll do the video now. But anyway, so it has all the little parts there. So the head is big, but it's a baby, so that's expected. The spines, the bumps do the same. They start, very accurate. There's one in the middle, and the 2 little bumpy rows, and then it goes into where they come together. That's super awesome too, actually. But anyway, so Amargasaurus in and of itself, what's the story? Where's it fit in, right? Let me use, let's see, for size comparison, this guy here. So one thing to point out Amargasaurus is time. So I've been really pushing the idea of geography on you kids, and where does it live, when does it live, right? So Amargasaurus is found in South America. So the first thing you think is, wait, isn't Argentinosaurus found in South America, and Carnosaurus found in South America? Carnotaurus, not Carnosaurus, Carnotaurus, and Saltosaurus, for example? The answer is yes, they are all found in South America, but they're found in different parts of South America at different times. So Amargasaurus lives about 125 million years ago. Argentinosaurus is about 100 million years ago, and Carnotaurus is about, I think, 85 or 75 million years ago. So even though they're all in the same region, and in fact the same expedition that had this guy found some, this guy, I believe, same project, they're from different times. So whenever we say, you hear in like pop culture, separated by time and space, literally, they're separated by different time periods, even though they're the same continent, different parts of the continent. So what I'm saying is, by the time of Argentinosaurus, the Amargasaurus had died out, it was fossilized. And then this guy was living, and then it died out and fossilized, and then this guy was living. So even though you're in South America, there's still these different time frames. But the last thing to point out real quick is its ecology stats. So if you look at the late Jurassic North America, herbivores, big herbivores, sorry, you would have Diplodocus, Camarasaurus, Apatosaurus, aka Brontosaurus. Well, now Brontosaurus is back. Stegosaurus and Brachiosaurus, to name a few. So you're like, you have all these sauropod long necks in one environment. What's going on? They all eat different plants, different ways. That's why in Africa, for example, we have a lot of competition between carnivores. You know, hyenas and lions are fighting each other, leopards and cheetahs and stuff. Well, cheetahs are being bullied, really. But the idea is they're all eating meat. Although lions tend to go larger prey, cheetahs smaller prey, they're still eating the same thing. But the wildebeest and the zebra and the buffalo and the elephant, they're all not competing as much. They compete for water, but not for food because they eat different kinds of food. The wildebeest has a wider mouth. The horse has, the zebra has a more narrow mouth. The antelope have very narrow mouths. So all of these sauropod, long necks, in North America and Stegosaurus have different mouth designs, and they're eating from different ranges. So there's a whole lot of cool studies on this. If you go to Africa, for example, at the same time, we have, this is a Brachiosaurus, but it represents Giraffatitan. This is a Kentrosaurus, another stegosaurid, basically. And there's an animal called Barosaurus, which is like Diplodocus, and it's in the American History Museum in New York, and there's not one toy or a decent toy of Barosaurus. Some of these are Diplodocus as representative. They're found in North America too, but also in Tanzania. So this is what we're seeing in North America, South America. This is kind of common for the Jurassic, this assemblage of herbivores, and a lot of tiny little bitty ones too. In South America, in the early Cretaceous, what we're seeing is the Southern Hemisphere, South America, Africa, India, Australia, it tends to retain the Jurassic design. Because in the Northern Hemisphere, in the Cretaceous period, we're starting to see raptors and rexes and horned dinosaurs and duckbills. But the Southern Hemisphere kind of matches the North in the Jurassic. So Amargasaurus, where is it? Well, here's our, so Amargasaurus, it's been found with other sauropods, essentially a early type. This is a Saltosaurus, but like a titanosaur. And there is a dubious stegosaurid, Amargastegos, which people are debating. But I'm using this Kentrosaurus as a model. And there's other high brother sauropods. So what we're seeing basically is the same thing we see in the Jurassic period in the Cretaceous South America. In some ways, Amargasaurus and Dicraeosaurus in general take on this very small sauropod feeding, or like almost big Stegosaurus, different groups, feeding style or ecology niche. So that's something worth noting, that we see this continuation of that. And then if, whereas the Northern Hemisphere, because Pangea breaks into two parts, where it's North America, Europe, and Asia, and here we have the raptors and rexes and all those guys evolving, and Ankylosaurs in great numbers. In the Southern Hemisphere, it's more sauropods still kind of reign supreme, right? And then all the giant carnosaurs, right? So that's something to point out too, why these guys may have gotten so small, because they're living with other sauropods that feed high, have other specialties. So their niche in the environment was to get smaller and to eat that way. With that being said, the video is already too long, and I won't go into any more detail, but this is Amargasaurus. If I get an Amargasaurus figure, the Jurassic World one, or even the PNSO one, or if they're gifted to me by some chance, I will do a part 2 of this video. But until then, I will see you next time.